Let's begin with the background of our study. Today, smartphones are used by almost every student for many different reasons, like studying, social media, and entertainment. However, many students may not realize how much time they actually spend on their phone. This unawareness could have an impact on their academic performance. So, in this study, we aim to explore the relationship between phone usage and academic results using statistical method. This slideshow is the main goal of our study. First, we want to determine the strength of correlation between phone usage and academic performance. This means we are checking if there is a strong or weak relationship between how much students use their phone and their CGPA. Second, we aim to find the regression line that represent this relationship. This line helps us understand the trend and make prediction based on the data. These objectives guide our analysis and help us draw meaningful conclusions from the study. This study is important for a few reasons. First, it helps raise awareness among students about their phone usage habits, which many may not realize are affecting their academic performance. Second, it provides useful insight for educators, helping them create strategies to better support students in staying focused on their studies. Lastly, it encourages students to develop healthier digital habits which can lead to better academic and personal outcomes. Overall, this study aims to make a positive impact on both learning and lifestyle.
Okay, here are my slide. Limitation of study. This research is limited to a sample size of 32 students from Uitm Campus Bukit Besi, which may not fully represent the wider student population. Additionally, the scope was narrowed to mobile phone usage, excluding other digital excluding other digital tools like laptops, tablets that are integral to academic life. So here are the methodology. For this study, we use a simple random sampling method to examine the relationship between phone usage and academic performance among students at UITM Campus Bukit Besi. We collected data using a Google Form questionnaire, which included questions about students' daily phone usage and their current CGPA. A total of 32 students from various programs participated in this study. Once the response were collected, we analyzed the data using descriptive statistics and regression analysis with SSPS software to identify patterns, correlations, and the strength of the relationship between phone usage and academic performance.
Hi, on this slide, we look at three variables in our project. Gender is qualitative variable. It measures on a nominal scale, which means it just categorized like male or female. CGPA is quantitative and measured on a interval scale. It's a number, but it doesn't have a true zero. The last one is phone usage. It is also quantitative, but it's on a ratio scale, which means it has a true zero and we can compare amount directly. Let's quick look at our variable. On this slide, we're showing how we use different chart to present our data. First, we have a bar chart that compare gender with phone usage. This helps us see how phone usage differ between gender. Next, there are two histograms. One show the distribution of CGPA and the other shown the distribution of phone usage. This helps us understand how the value are spread out. Lastly, we have a scatter plot that shown the relationship between phone usage and CGPA. This helps us see if there any pattern or link between how much someone use their phone and their academic performance. This visual make it easier to understand the data at a glance. Here, we show the descriptive statistic for phone usage and CGPA. The mean phone usage is 7.47 hour and the average CGPA is 3.48. The median value are 7 hour for phone usage and 3.545 for CGPA, showing the median value in our data. The most frequent value is 7 for phone usage and 3.7 for CGPA. The first quartile show that 25% of CGPA use their phone less than 6 hours and have a CGPA below 3.29. The third quartile show that 75% use their phone less than 9.75 hours and have a CGPA below 3.7. The standard deviation tells us how spread out the data is 2.31 for phone usage and 0.35 for CGPA. Skewness is negative for both, meaning the data is slightly skewed to the left. Lastly, the coefficient of variation show that phone usage varies more than CGPA, with 29.47% compared to 9.97%. These stats help us understand the overall trend and spread in our data.
This slide shows the correlation and regression result. We found a correlation of negative 0.59, which is mean there is a moderate negative relationship between phone usage and CGPA. The regression line is CGPA equals to 0.15 multiply phone usage plus 2.2, which we use to predict CGPA. However, the R-squared value is very low, only 0.0035. This means usage phone usage only explain 0.35% of the change in CGPA. So, phone usage has some effect, not a strong one. From the data, we can see the correlation is weak. This means that most of the change in CGPA are influenced by other factors, not phone usage. Interestingly, the result goes against what many people believe, as our data show CGPA slightly increases with more phone usage. In conclusion, for objective 1, we found a weak but positive correlation between phone usage and CGPA. For objective 2, we developed a regression model CGPA equals 0.15 times phone usage plus 2.2. However, we need to be careful when interpreting the result because the other factor may also affect CGPA. Thank you.
Based on our findings, we propose a few key recommendations for future research. First, it's important to include more variables in future study to capture a wider range of factors that might influence the result. Second, using a larger sample size can significantly improve the accuracy and generalizability of the findings. Lastly, we suggest differentiating type of phone usage, specifically distinguishing between academic use and entertainment use. This will help in identifying more specific pattern and impact. In this slide, we elaborate on the value of the slope B obtained from the SPSS output, which is 0.15. This slope tells us the rate of change in CGPA with every additional hour of smartphone use per day. Specifically, for each additional hour spent on the phone, a student's CGPA is predicted to increase by 0.15 point. For example, if a student uses their phone for 8 hours a day, their predicted CGPA would be 0.15 multiplied by 8 plus 2.2 equal to 3.4 based on the linear model. Now, let's look at an example of how to make a prediction using the regression equation from our data. In this scenario, a student used their smartphone for 6 hours per day. To predict their CGPA, we simply substitute this value into the regression equation. CGPA equal to 0.15 times 6 plus 2.2. CGPA equal to 0.90 plus 2.2 equal to 3.10. So based on this model, the predicted CGPA for student with 6 hours of daily phone usage is 3.10.